different types of triangles. There's an equilateral triangle that has 3 equal angles, 3 equal lengths. We normally show equal lengths by putting the same mark on the lengths on sides that are equal. And what angles what measure of angle are each of these? 60 degrees. Good. So we know they're all 60 degrees because we know they add up to 180 and they're all equal. Isosceles. Isosceles has 2 equal lengths, okay, and 2 equal angles. If those 2 are the lengths that are equal, then these 2 would be the equal angles, okay? So they're known as the base angles. Same rule applies, they all add up to 180, so you can often work out one of them knowing that what the total is. Right angle triangle has one right angle, that's the only specification for right angle triangle. And scalene triangle has no equal lengths and no equal angles. Okay, so just be aware that that's the kind of triangle it is. A right angle isosceles triangle would be a right angle triangle where those 2 sides are the same.
Why do they just that?
Because it gave away what isosceles was. I don't know actually why. Maybe I can find a different one. Alright, so. Oh gosh, that's really good.
Wait, good question. You're right.
No, these aren't quite the same length. Yes, so for a right angle isosceles triangle, these 2 lengths have to be the same length, yes? That's why they've got those markings. Yes. Your diagram may not look like it, but they should. So, if we have a right angle isosceles triangle, we know it's got a right angle, we know it's an isosceles triangle, so what does that mean? These angles.
Equal? 45.
And how much would they be?
45,
yeah.
45, 45, 90, 90, 90.
Okay, so for the right angle isosceles triangle, we've got 2 angles of 45, 1 at 90, and then our lengths are shown. Okay, everybody else? Oh, why have I got that again? Have you got that again?
Yeah. I have all
Yeah. Oh, it's all different. Oh, bless my heart. Oh, alright, okay, so all triangles, we know they add up to 180. So if we know that this is an equilateral triangle, what do we know that each of these are? Okay. This bad boy here, we've got a 60 and an 80. How do we find D?
Equals 80 and minus half or 180 minus 40.
Okay, the reason, if we were to give a reason, and remember that the reason is not this, the reason would be what?
Angles in the triangle add up to 180.
Angles in the triangle add up to 180. Okay, so the reason, if we had to give one, was angle. I like to say angle sum of triangle, just because it's a little bit shorter. Okay, so that's angle sum of triangles, we know they add up to 180. Trivia. We did discuss this briefly last time, but when they are labeling them alphabetically, you'll tend to be advised to try and find them alphabetically. Does that make sense? So this one, they're encouraging you to find E first.
Oh, that's easy.
Okay, so E would be what?
40.
So E is 40, and the reason is because it's the base angle of an isosceles triangle. Okay, so again, the reason is because it's the base angle, not, you don't just write it's 40 degrees. And then F, what would F be? And what would the reason for that be? Yeah, so angle sum of triangle. If we know this top angle, G and H,
180 minus 30 is
and we divide them by 2 because, but why do we divide them by 2?
Because the 2 angles are equal.
Alright, so the 2 reasons for both G and H, so we can say G equals H, and they both equal 75, and again the reason would be angle sum of triangle, but also the base angles from an isosceles triangle. So you'd need both of those two reasons in there because we've used both of those facts to calculate them. Does that make sense? So even if you're not having to write down one reason, sometimes you do need two reasons for when you're calculating stuff. This one here, the diagram, remember I said the other day, it will often say the diagrams are not 40 scale. So this one's 40 scale. So I know this one's 90, this one's 45. So I know this one has to be 45 degrees. And for this we could just use angle sum of triangle.
Or right angle triangle.
Or you can say it's a right angle isosceles triangle. Show off that you recognize that. Okay?
So you just do, oh, you already know it's 45?
Yeah, because we know that we just talked about this, didn't we? Because if that's 19, 140, that's 45. We know that the other is 45. Angles of quadrilateral. What's the shape? No messing with you lot. We know that all four angles in this quadrilateral are how much? Makes so long. Okay, so is it true for all quadrilaterals? So do we know that all four-sided shapes add up to 360?
Yeah.
Okay, we do. Excellent. One way of showing that, just in case you forget, the fact that I'm going through this with you now is just a hopefully good reminder. What you do is you essentially cut your shape up into as few triangles as possible. Now I can, for this four-sided shape, I can cut it up into two triangles. Yes? We green. What? Okay, alright. So we know that these angles here add up to 180. We also know that these angles here add up to 180. And those angles make up all of my interior angles. Do you see that? Yes, none of them are like in smack bang in the middle. So because of that, we've got two lots of 180 here, which makes 360. Do you follow that? So to find out what we can do to find out any sum is see how many triangles we can cut the shape into, and that will tell us how many lots of 180 there would be in there. That's why it says the fewest triangles. Yes, because otherwise, as you said, you can start chopping through left, right, and centre. But if you can, the fewest triangles that you can possibly cut.
Wait, so 2 times 180. Oh, so we don't have to find it.
No, I was just showing you that these angles here would add up to 360 because there were two lots of triangles that made up the full triangle. Yeah? So if I had, let me draw another one. So let's draw any five-sided shape. 1, 2, 3, 4, 5.
What's that?
Okay, you can draw any old five-sided shape.
You have 3 sides.
So if I were to cut this one, I would be able to cut it there and there. Or you may have gone the other way, doesn't matter. But the minimum number of triangles you can cut is 3, yes?
And there's one more triangles at work? Why can't you just do 1?
Because you wouldn't have to do triangles. If you just drew one line, you wouldn't have triangles.
You have 1 triangle and 1 square.
And one quadrilateral, yeah.
So if it doesn't go into one, if it doesn't make triangle, it always is not.
They will always be, you would always be able to make a triangle with a polygon.
No matter what triangle goes. But like, if it's not a quadrilateral, it won't be triangle.
No, it will just be no color. So that's what this is. No. Seriously, please. I've tried to explain it for a while, so people making noises and singing and doing stuff just really frustrates me. Ask me again. So if it's not a quadrilateral, no. So we're talking about any kind of polygon. So that's any number of sides it has. So this one was a 5-sided shape. So I was able to cut it like this and this. Okay, so I've cut it into triangles. And now I know that then these ones add up to 180, these add up to 180, and these add up to 180. That means that my total here would be 3 lots of 180. So all of my interior angles here would add up to that. We're going to go through this again in a minute, but this is just a side note of how you do it.
So you always have to go angle to angle?
Vertex to vertex, yeah.
That's 5 times, and that's a polygon. So any kind of polygon still has angles that add up to 360.
No, so this quadrilateral with 4 sides added up to 360. This pentagon, 5 sides, added up to 540.
Oh,
So they add up to different numbers depending on how many sides they have. Okay?
is it every side you add, there's another triangle?
Yeah, we'll talk about that in a second, but there is a pattern. Alright, so we're comfortable that some of the angles in the quadrilateral is 260. So if I know that these 3 angles are 65, 130, 95, I can just find this one.
You add them and then.
Do we know what these add up to?
290.
Okay? Okay, so D is 70 degrees, and the reason for that would be angle sum of quadrilateral.
You have to put the degrees on.
You ideally would. I can't imagine they would deduct the mark for not having it.
And they're working out. You want the degrees on the block?
If you'll find the marks.
It's like on a line.
Alright, and the last bit, opposite angles in a parallelogram, do we know this?
Yeah.
Equal.
Okay, so opposite angles in a parallelogram are equal. Okay, what? Okay, so a rhombus is a parallelogram. A parallelogram is not always a rhombus.
So what's a rhombus?
So, let's go with parallelogram first. So a parallelogram has 2 pairs of parallel sides. Okay, so that has 2 pairs of parallel sides. Now the thing with definitions of stuff, now notice I've got different symbols here. I've got 2 arrows here to show those parallel. The definition of 2 pairs of parallel sides also means that a square would fit into that category. A rectangle would fit into that category. Okay, so you have lots of shapes that fit into certain categories, but it doesn't work both ways. Okay, so the definition of a parallelogram is 2 pairs of parallel sides. The definition of a rhombus is that it's 2 pairs of parallel sides, all of which are equal. Okay, so a rhombus has to have all 4 sides the same. It's a wonky square. Yeah.
Where on the
Thing. Because like if it was 90 degrees, it would be a square.
So is a square rhombus?
A square is. A rhombus is not square because it's a square and it's 90 degrees. Okay?
But are all angles non-equal?
In a rhombus? No, because of the slot.
Are any of them equal?
No. Yeah, 2 pairs. Because we know that there's for the opposite.
Okay. Oh, that's what I'm
Okay. Right, external angles in a triangle. Do you all know this one?
Oh, the thing on the right is equal. Find the angle of that
Alright,
one.
okay,
And the one
so,
that is 80.
alright. Now, we could take a longer route and say, okay, well I know that this is 30 and this is 100, and so that makes 130, which means that this angle here is 50, and then find this one here by saying, right, that's 180 subtract 50. Well, what do we get? Do we notice anything special about that?
So base that, yeah.
Yeah, so this exterior angle here is always going to be equal to the sum of these two interior opposite ones.
That's so weird.
Okay, but I'm asked why. Well, we've just shown you why. Because the nature of the exterior angle is that this line continues out. Okay, and so this exterior angle is always going to make 180 degrees with this one. And we know that the angles in a triangle add up to 180, so therefore these two must always make 180 with this one.
So when there are two angles on a line, you should always add to those, so you don't include the 30.
Yes, correct. It's really important, and that's something lots of people do. You asked me about that the other day, yes? When we say angles on a straight line, these are the two that meet on that straight line. Do you all appreciate that whilst this one is on the same straight line, it's nowhere near it? Yes, it's nowhere near these two meeting. I always like to try and encourage people to look for something that looks like a protractor. Okay, you know a protractor is 180 degrees, so these are the two that make up that 180 degrees. This bad boy's got nothing to do with your protractor, it's a bit that's fallen off and broken in your head. Okay, so that's nothing to do with it, this is your 180 degrees.
So if you, okay, down to 30, if you extend the line,
so if you were to extend this line, then this angle here would be equal to the sum of these two.
Okay.
Okay, so the exterior angle is equal to the sum of the two interior opposites. Okay, so not the one attached to it, the other two. Alright? So here, in general here, this is the exterior angle, these, it's going to equal A plus B. Okay, so let's write that in words, shall we? The exterior angle is equal to the sum of the two interior angles opposites. Okay? So the sum of the exterior angle is equal to the sum of the two interior angles opposite it. Now, it's not the law that you remember this angle, because obviously we did just work it out using common sense. But if you choose to use this method, you just need to write one reason down. You can use the reason that it's the exterior angle of the triangle. If you choose to use the other reason, you must write down angle sum of triangle and the angle on a straight line at 180. Okay? So it just takes a little bit longer in your working or your reasoning for it. This one, you can just write down one reason. Okay? But remember, as I said the other day, there's lots of different ways of finding angles, and there's lots of different reasons that can be given, and you can all be correct. Okay? So it's not the law that it has to be this one versus that. Any questions about that?
Can you do the control?